My name is Francisco Bencomo, and the topic I chose for my presentation is data mining. Data mining is the computational process of discovering patterns in large data sets involving methods at the intersection of artificial intelligence, machine learning, statistics, and database systems. That's kind of like the formal definition of it. A more kind of general definition, it's just a process of extracting interesting patterns and knowledge from large amounts of data. And when we talk about data mining, we're not just talking about pulling any information off of out of a database. It's generally, it's always done in a way that has a purpose. So a company wants to find out a little bit more information about either some products or some sales or maybe some scientists. They want to make some correlations between weather patterns or things like that. They will use data mining to analyze data that they've collected, and then they can make discoveries about that data, and it will assist them. If you're in the retail industry, it'll assist you with making sales, kind of maximizing your profit opportunities. If you're in a different community, like I was talking about a few seconds ago about meteorology, then it'll assist you with kind of predicting weather patterns or predicting types of weather for certain areas. And data mining, it's a step of the knowledge discovery and databases process, which is it's kind of something that came along as data mining was starting to get more sophisticated. Everybody that was building upon that process, they decided that a process needed to be established to do the data mining more efficiently and more successfully. A little bit of history about data mining. Extraction of patterns from data has occurred for centuries. So before computers, obviously, it was all done by hand. A lot of it was using kind of mathematical theorems like Bayes' theorem, and then there's also another way, regression analysis. As computers came along, though, we obviously started using computers to do data analysis. And as the power of the processors and the storage capacities with computers grew, so did data collection and so did data manipulation, which is also data mining. And then with the increases in the size of data sets, hands-on approach to data mining was replaced with automated data mining. A little bit more about the knowledge discovery process. It's the process of discovering useful knowledge from data. Obviously, it involves the evaluation and possibly interpretation of patterns to make decision of what qualifies as knowledge. It also includes the choice of encoding schemes, pre-processing, sampling, and projections of the data prior to the data mining step. So basically, you're kind of getting an idea of what you're trying to discover. You're also figuring out how the data that you're going to discover this from is set up, like the relational schemas and whatnot, and how you're going to manipulate the data to get the information that you want. And then you start the data mining, and then after data mining is completed, you evaluate the results of your data mining. And the steps, again, are selection, pre-processing, transformation, data mining, interpretation, evaluation. And then the problems that data mining solves, it's kind of spread out over almost all industries now, because so many industries are using computers so much. And in order to improve, whatever industry that they're in, they can use data mining of the data that they're collecting. So whether you're a retail chain that's collecting data on your customers' purchasing habits, or as I discussed earlier, you're a meteorologist and you have machines that are out in different areas collecting environmental or weather pattern data for you, um, you're going to be able to use data mining to discover certain things about that data. So if you're in the retail chain, you're discovering how to maximize your profits, or small things like if a man goes to buy diapers on Thursdays and Saturdays, he's likely to also buy beer. And so you can, as a retail chain store or as a retail store, you can set up a display of beer in an area very close to where diapers would be purchased. Um, that's the kind of power in data mining. That's the kind of power that it has, that it can give you those really small things that can aid in either, like I said, increasing your profits or just improving your processes overall. Um, and again, it's useful for the predictions, which is again in meteorology. So they have their machines that are out, collecting precipitation information, or they have satellites that are taking photographs of certain geological areas and what the clusters of clouds look like at certain times of the year, and they can use the history of the data mining, or they use the history of the data and use data mining to kind of gather patterns, and so that it'll allow them to predict um, weather behavior in those areas. This is one of the techniques that the retail stores will use. It's called market basket analysis, and it's a theory that if you buy a certain group of items, you're likely to buy another certain group of items. So it gives you clues to what a customer may purchase if the idea occurred to them. So as an example, if a customer goes to the grocery store and they buy chips, then they're also likely to purchase dip to go along with their chips. So then the stores can set up the orientation of their where they're stocking their food items. Where they put the chips, they'll also put the dip, um, and other things, like they have the powders that you would also mix in other things like a sour cream. You can't necessarily store the sour cream where you store the chips, but you can store the powder there, which will then have them go and purchase the sour cream. So the market basket analysis allows the retail store chains to kind of draw those conclusions, that if they put the chips in this location and they put the powder in this location, then it's going to also have the customer go and buy the sour cream, and they can evaluate whether or not their location of those items is working, because every time a person goes and buys that powder, if they go and buy the sour cream and also the chips, then they know that they've done a correct analysis of what a customer will do if they buy the chips and they buy the powder. So again, it allows them to use the information to arrange the location of products in their store. And then it also helps them with promotions. So you can set up displays of items that are on sale for a certain amount of days, because using the data mining, the retail stores can see on what days they can charge more, or they can have the items displayed at their full value. So as I was saying earlier about the men going and buying the diapers and the beer, they can put the prices at the full value on Thursdays and Saturdays, because they know that the men are more likely to buy them on those days, and then they can lower the prices to kind of entice them on other days when they're less likely to purchase them. All right, and clustering is it's a method of data mining that's used in the meteorology example that I was discussing earlier. What it is a division of data into groups of similar objects. Clusters correspond to hidden patterns. The search for clusters is unsupervised learning, and the resulting system represents a data concept. So clustering is very useful when you have a large collection of raw data, like in meteorology. They have machines that are out again measuring certain things about weather or other climate data, and most of it's just raw data. It's not really organized. It's not really structured in any specific way. But what clustering allows them to do is to kind of put that raw data together and make relations so that they can make sense of the data, after they've recorded it, it's raw, and then after they do the clustering, now they can make sense out of it. So one example is using the data to determine precipitation weather, a precipitation weather type by finding the similarity between, as I was saying earlier, satellite cloud images, seasonal clustering, and climatology. And usage, again, data mining is currently being used in a wide variety of industries. I've just named two of them, in retail and in meteorology. But again, those are just two of the many. There's industries like in medicine, they're using it. In banking, they're using it for things like fraud and also detecting um, uh, fraud and credit card use. And then almost any field of science, biology, they're using data mining. Astronomy is using data mining, and then even um, e-commerce and also uh, like online um, social websites like Facebook and Instagram and things like that. Google is also using it. It's just ways that they can improve their processes. Like Facebook uses it to place ads and place things that you're more than likely to click on. They call it like clickbait. They put a lot of clickbait based on information that they're gathering from when you're browsing the internet, or clicking through your Facebook page. The advantages of data mining, in the modern way with computers, not doing it by hand, is that we're able to sort through massive amounts of data with a purpose. So we're not just sorting through it to find one specific type of data. We're sorting through it to find relations, and we're sorting through it to find patterns that are going to help us either improve something or help us discover things that we have kind of like a hypothesis on. And then we can use data mining to prove or disprove what our belief was. And then also, now that it's automated, we're able to discover patterns in the data much more quickly than if done by hand. And then a huge advantage of data mining and why it's becoming so widespread is that it's so versatile, and it can be used in almost any modern industry that does large collections of data. And then some of the disadvantages of data mining are privacy. In order to be able to do data mining, we have to collect large amounts of data. And obviously sometimes we're collecting data that's addresses. For banks, it's bank account information. For companies, they have a lot of their customers' information, addresses, phone numbers, sometimes like purchase history, things like that. And they are susceptible to hacking. There's already been, several cases of companies that do collect large amounts of data being hacked and having that data stolen. And then there's the misuse of that data. So that could kind of tie into privacy. It can also be misuse of data as far as gathering that information and not really interpreting it correctly, and then not using it in a way that is beneficial. You just collected this huge amount of data, and now you're not using it in a beneficial way. You're kind of wasting the data. And then another misuse would be something like collecting all of this data and then selling it to a company that could use that to kind of be predatory to customers, or some other relation between the company and whoever they're trying to get to buy their products. And then also, again, security, which is the hacking. And this also ties into privacy because Companies like Facebook and Google, and then some phone companies, and then even the government, they have huge amounts of our own personal data. Again, addresses, and then even the government, they have our social security numbers, things like that. And we're unaware, most of us are unaware that the data collection is happening, that they're collecting all of this data from us when we go to these websites like Google and Facebook. As we're clicking through them, it's just going to this huge database that they have, and almost, there's several other companies that do the same thing. And it does cause security issues because, again, they can be hacked and they can take that information and misuse it. And then, we're kind of at the mercy of whatever those people decide to do, or however good the security is of the companies collecting that data. And then some technologies that are related to data mining, any database language like SQL. I spelled that wrong. It should just be SQL. So like SQL are used in conjunction with data mining to kind of employ the techniques. The languages will allow you to create the relational schemas that will allow the data to be manipulated. So you can, in order to do any kind of data mining, you're going to have, well, I guess I shouldn't say any kind of data mining, but most kinds of data mining, you're going to have the data organized in some way, so that when you go to manipulate the data and you go to extract certain things out of the data, the program that you're using will know how to search through it and search for what you're wanting to look for. So again, those languages are a technology that's huge in assisting with that. And then another thing, it's kind of obvious, but it's worth mentioning. Computers and storage devices are technologies that are also used in conjunction with data mining. The reason that it's worth mentioning is because as the power of processors and computers, and also as the size of storage capacity grows, the effectiveness and the possibilities of data mining are also going to grow with that. When we start talking about getting into computers, and with I believe it's called quantum processors and things like that, they're going to be a lot faster, a lot more powerful, capable of doing many more things than what the computers that we have can do now. And then also when the storage capacity, as it gets bigger, we're going to be able to store larger collections of data, and probably in several different ways. And then with the new power of the processors, it'll be able to manipulate that data, extract data out of it much quicker, in much different ways. I mean, you might even get into things about, you start talking about artificial intelligence. I think there's a lot of research going on right now, and how data mining is going to be able to assist us with making progress in artificial intelligence, because the computers are able to learn as they are data mining. So they'll be able to pick up patterns in the data, and they'll be able to, quote unquote, learn from the data and the patterns that they're collecting. And then using those patterns, they'll be able to recognize other patterns, and then it just kind of compounds on itself as they're continuing through the data, looking for more and more relations. And these are my references, and that's my presentation on data mining. Thank you.